Calculus kids, this is Dr. Callahan. How are you guys doing? Welcome to week 13, Thursday. Go ahead and pause the video and answer the following questions for your warm-up. All right, so go ahead and take a look at your answer for the warm-up for your slope field. Just remember that this is essentially just a field of slopes, and you're just looking at the dy over dx, which represents slope, which is the same thing as y prime. And notice that there is no x value, so whatever x value you have, it should be consistent with all the x values that you are locating the points on, and your slope field should look something like this. All right, so today is going to be the second day, or the third day actually, of reviewing for your AP College Board exam. So today we're going to talk about a quizzes, which is going to go over limits analytically. And let's go ahead and get started with that first. So here is your quizzes. If you're doing this at home, you're welcome to go ahead and practice on your own. And let's go ahead and get over here. So let's go ahead and do this one. It's going to be 25 questions. I'm going to go ahead and assign it to you guys. You have until 3 p.m. Thursday to complete it. And just go to joinmyquiz.com, insert the code 1722-1938. All right, so with that said, let's go ahead and take a look at the rest of your stuff today. I am going to have you guys take a look at one of the free response questions. So this is the one that I want you guys to read. So pause the video and read it. There are four parts to it. All right, let's go ahead and take a look at the first question over here. So the first part A, it says, to the nearest whole number, how many cars pass through the intersection over a 30-minute period? Keep in mind that this is a question from 2004. It's the first question, and it's also a calculator question, so you will need to have a TI84 calculator to do this one. So looking at this, so for your part A, since it is between 0 to 30 minutes anyway, let's set the integral from 0 to 30, and f of t is going to be measuring the cars per minute, which is equal to, and you have 82 plus 4 sine t over 2. And so what I suggest doing is on your TI84 graphing calculator, make sure you go to graph, y equals, make sure you put that right here, and then go ahead and click on graph. And then what you want to do with this is you want to go to math, because you can actually integrate this without doing this by hand. And the way to do that is you will go to math, you will go down to 9 FNINT, which is a function of integration, on your TI84, and then you're going to type this in there. And you're also going to be expected to include the integrals of 0 to 30. And then once you go ahead and hit enter, you should have this entire thing equal to 2474 cars for part A. Part B, is the traffic flowing, increasing, decreasing at t equals 7? Well, in order to do that, you would have to find the first derivative, which will tell you the max and min functions of this. And also it's going to tell you if the slope is a positive or a negative when you plug in the 7 in there. And that essentially would tell you whether if it's greater than 0 or less than 0, because if f prime of 7 is greater than 0, then the traffic flow is increasing at t equals 7. However, if f prime of 7 is less than 0, then the traffic flow is decreasing. So then what we're going to do is we are going to find the derivative of f of x with a TI84 calculator. And to do that, what you're going to do is you are going to hit the button Math, the button 8, and the button in DRIV, and you're going to insert the function of it, and the function is f of t, which is going to be 82 plus 4 sine t over 2, comma, and then you're also going to insert the x value, and then lastly 7. Once you go ahead and hit enter, you should see that f prime of 7 is going to be a negative 1.872, and your answer should be since f prime of 7 is less than 0, that means the traffic flow, you could say, in which it indicate the traffic flow is decreasing at t equals 7 minutes. And that is for B. All right, so for C, it says, what is the average value of the traffic flow over time between the intervals of 10 to 15? So then your average value theorem is going to be the integral with 1 minus b minus a, or 1 over b minus a. So your a is going to be 10, and then your b is going to be 15. A to b f of t dt. So let's plug this in. 1 over 15 minus 10, integral 10 to 15. And f of t is going to be 82 plus 4 sine t over 2. Plug that in to your calculator, and you should have 81.9 cars per minute. All right, now I'm going to go ahead and take a look at part D. Says, what is the average rate of change? Keyword being average rate of change, which makes me feel like it's like slope, which is f of b minus f of a over b minus a of the traffic flow over the interval 10 to 15, indicate the unit of measures. So here's your a, here's your b. So then what you're looking at essentially is going to be the average rate of change for the traffic flow is going to equal to the change of traffic flow, which is the y's, divided by the change of time, which is represented by x. So looking at this here, you're going to have to find f of 15 minus f of 10 divided by 15 minus 10. To find the f of 15, the best way for you to do this is just go to graph y equals 82 plus 4 sine t over 2. You want to do a second calc, and then you want to put in the x value as 15 and then the x value as 10. And then once you have those two values, subtract them and then divide it by 5, because 15 minus 10 is 5. And your average rate of change is going to be 1.517 cars per minute squared. And that is your answer. All right, let's go ahead and take a look at the next one here. Okay, so after reading this, notice that there are 4 parts to this question. And let's start off with part 1. How much sand will the tide remove from the beach during the 6-hour period indicated in measures? So for part A, you're going to look at from the 6 hours, so from 0 to 6 on your integral, r of t dt. And so you are going to plug this into your calculator. So the integral of 0 to 6, 2 plus 5 sine 4 pi t, which will put x, over 25, and then you will go ahead and evaluate this. So hit enter on your calculator and you should have a 38.815. And this is going to be sand removed from the 6 hours. And you also might want to put cubic yard of sand removed. There you go. Let's make sure we have complete sentences. B, write an expression of y for the total number of cubic yards of sand on the beach at time t. So what they're asking you is for the total amount of sand, which is going to equal to the, obviously, the initial amount, plus the amount of sand that you added, minus the sand that you then removed. So then let's set this up. You will have y of t is equal to the initial amount of sand that was placed, contained 2,500 cubic yards, plus the amount of sand that was added on there. So you will do the integral from 0 to t, s of t, or excuse me, not s of t, s of t, yeah, no, that's correct, dt. And then minus the integral of 0 to t, r of t, which is the amount of sand that was removed, dt. So that would be your expression for that. All right, so part C asks you to find the rate at which the total amount of sand on the beach is changing at t time equals 4. So for C, the rate, which means we're going to do a derivative y prime of t is equal to d over dx from the integral of 0 to t. So s of t dt minus the integral from 0 to t r of t dt. And then in order to go ahead and evaluate these further, you know that y prime of t is equal to s of t minus, so the amount of sand added, minus the amount of sand removed. And you want to do this at time equals 4, so y prime of 4 is equal to s of 4 minus r of 4. So you want to evaluate this using your calculator at 2 different equations. One is s of 4, so you're going to be plugging this in your TI84 calculator and figuring out what that entire thing is when t equals 4. And then do the same thing with the second equation and on your TI84 calculator when t equals 4, so plug that in. And the best way to do it is if you just go ahead and graph y equals, let's say we're working on this one here, 2 plus, I will do a parenthesis, 5 sine parenthesis 4 pi x divided by, because you don't have t on your calculator, 25 close parenthesis, hit the graph button, second calc, x value, insert the 4, and then hit enter. And that should give you a number of what that number is evaluated for the r of t when t is equal to 4. Then when you subtract these two numbers from each other, your finalized answer should be at negative 1.908 cubic yard per hour. So what is the rate of the total amount of sand on the beach that's changing? You're losing about 1.9 cubic yard an hour. All right, you guys, then looking at the last part right here for D, it says, between 0 and 6, at what time is the sand on the beach a minimum? What is the minimum value? Justify your answer. Well, to find the minimum, you will have to find the first derivative, and then you will have to go ahead and set it equal to 0. So you should say that the sand is at a minimum. When y prime of t is equal to 0, because that's going to give you your critical point. So what you can perceive from that is s of t minus r of t is equal to 0. And so from there, you know that your relative minimum is going to be at t equals 5.12. So then you can also, let's test the minimum. If your t value is going to be, of course, at 5.12, that's your critical point. But then also at t equals 0, and then t equals 6. So let's go ahead and figure that out. So I have y of 5.12, y of 0, y of 6. I'm going to look at the y value to see which one has the lowest y value. At 0, it is going to give you a 2500. At when t is 5.12, it's going to give you a 2500 plus the integral of 0, 5.12, s of x minus r of x dx, which is then when you plug into your calculator, it's going to give you a 2492.37. Do the same thing with 6. You have the 2500 because that's your initial amount of sand, plus the integral of 0 to 6, s of t minus r of t dt. And if you plug that in, it's going to give you a 2493.3 cubic yard. So then looking at that right here, the absolute minimum for this, which is going to be the smallest amount. Oops, where's that go? Comparing them is going to be this one right here. So at t equals 5.12, you should be able to say that the absolute minimum is 2492.37 cubic yard of sand, and that is when t is at 5.12 hours. All right, you guys. So now that we answered and justified for the 4 parts, I want you guys to take a moment and take a look at the answers of a grader and how they will be grading you for this. So looking at this, for part A, it's worth 2 points if you have the integral answer with the units. Part B is worth 3 points if you integrated it, limits, and the answer. Part C, it's just 1 point if you have the answer. And part D, you have 3 points. You have y prime set equal to 0. You found the critical value, and your answer is with a justification. So take a moment and just kind of absorb that to make sure that when you're doing your free response questions, you are writing to the way that they will be grading. And a lot of it is you have to have the correct unit, and you also have to justify your answers in sentences. All right, you guys, so that pretty much concludes the 2 examples I want to go over today. For the remaining part of class, I just want to take you guys back over here and make sure that you guys are following along with Algebra.io. So you should be done with units that concluded on week 13 Wednesday. We're now moving on to derivatives, which is week 13 Thursday and Friday. So make sure you guys go ahead and get started with that. Make sure you pick 30 questions out of 128. And remember, everything for week 13 is due on Sunday by 11:59 p.m. All right, well, I hope you have a wonderful week. And as always, stay safe and healthy. I'll see you guys next time. Take care.